Hello everyone. Today we will talk about classification and clustering. So we will just introduce classification. We will not go in detail, but if any of you want to learn more about classification, you can take it as project, so separate course. For clustering, we will solve a couple of exercises and introduce a couple of methods of clustering. So let's first see what classification is. So our goal here is to classify our observations into already known groups. Those groups are called classes. We can formulate this problem a little bit different as finding a mapping, so a function from our input x to our output y, which is actually one of our groups. So if we have C classes, okay, then we can map each observation to our class. So what are we basically finding is some kind of rule to classify our observations into those classes. So we are finding some function rule. So when we collect new observation based on that function or that rule, we apply it and find in which class that new observation is going to be in. Depending on the number of classes, we can either have binary classification or multi-class classification. There is also something called multi-label classification, where, for example, the classes labels are not mutually exclusive. So, for example, you can classify a person as, for example, tall and strong. So in that case, you have multi-label classification because you have two labels. In this case, tall and strong. But when we say classification, we will usually mean this multi-class classification. So when we have only a single output, so for example, only tall, we don't want tall and strong, unless we state it otherwise. But because we will not go in details, this is enough. In terms of statistics, we can formulate this problem as function approximation. So we have that our y is a function of our input x, and then we want to estimate it. Okay, so we just, when we estimate it, we, for example, have y with hat, and this is our function that we use to classify our new observations. So similar to what we have done in regression. So we use still those independent variables to predict the dependent variable, but in regression analysis, the dependent variable is quantitative. In this classification or discriminant analysis, the dependent variable is qualitative, so categorical, tall, strong, or similar. Another important difference between the regression and classification is that the classification, you must less empathize on interpreting the effect that the independent variables has on dependent variables. So our, let's say, priority is to obtain the highest classification accuracy. So we don't want to be wrong many times when we classify objects, new objects. But for this topic, you can even take whole course and you would still not have time to cover everything there is. Let's see this example. As you can see here, we have some toys, and we have two classes of those toys. One corresponds to yes, and the other corresponds to no. So you have yes and no. For example, 1 and 0. So those are our labels. Usually when we have binary classification, so when C is equal to 2, instead of 1 and 2, we use 0 and 1. This is natural. So what we have is some kind of data. So we know already that there are some shapes belonging to this class and other shapes belong to the other class. So we can see here ellipses, for example, circles, squares, here stars or arrow or similar. Even here we have circle but red circle. So we can somehow describe this, okay, in a set of some features. So for example, color, shape, and size. Okay, so our input vectors, our x's, the numbers here can be either like discrete or continuous, or as you can see, combination. And for each of those attributes, okay, we have our label, so we know where to put it, in which class. This is the data that we have. So our x's and y's, similar to regression, where we have initially our, for example, p observations, and we have output y. So this is something that we observed here as well, and we know how to classify those objects. So we have three new objects that we want to classify in either this one or zero group. So we have this, it's blue like crescent, right? This is yellow circle and blue arrow to the right. But as you can see, none of those belong to either this group or this group, but we still want to classify them based on what we have here. So for example, from I, we can see that all blue things belong to this group. Okay, so we can put this percent into this group, so we can label it 1 or classify it in first group. However, for this circle, what we can notice here that we have circles in both groups, okay, and we can see that we have yellow in both groups. So we can make actually error, some kind of error when classifying this circle, either to left or to right group. So it's not clear where to actually put it, in which group. Similarly for the blue arrow, even though we have all blue here, right, but we have that arrow in this group. So where are we going to classify it? Those are the problems of classification. What we actually want to do is to minimize that error of misclassification. And that is going to be our rule for classification. As, for example, for this one, our rule was because all left were blue, and we do not have this kind of object in any of those groups. So our rule would be to classify it in the first one. So this is some kind of classification based on our reasoning or our logic. But we would need to interpret this in some kind of like probabilistic prediction, so using probability and using our data, our features, and our cases that we have. So there are actually many ways to use it and classify. But let's see what is actually the application of this classification, which is interesting actually. So classification can be used for many things, but the most use of classification nowadays is spam filtering. So for example, spam emails, how to filter what is spam and what is not. So how to distinguish emails from what you want to receive and what is actually a spam mail. So in this case, with spam filtering, you have only two classes. Either it is spam mail or it is not. Then some kind of generalization of this spam filtering is classification of documents. So here your goal is to classify a document, which can be, for example, web page or email, and you have more classes, so C classes, 5, 6, or many more. For that, you need to use probability and similar. One of the first classifications that you use when you start learning about it is classifying flowers. So there is a data set where the goal is to find a way to distinguish three different kinds of iris flowers. So those flowers are called Setosa, versicolor, and Virginia, or Virginica, something like that. So here you have three groups, and the data set gives you four features, like sepal length and width, and petal length and width of the flower. Another widely used technique is to classify an image. So for example, if you want to see if an image has a dog, or if it is your face on the image, for example, when Facebook tags you, or like if you're indoor or outdoor or similar, something like that. Special case of this classification of image is classification of handwritings. So there is also available data set of various people with various different handwritings, and you need to distinguish those. This data set contains only images of digits 0 to 9 written by those different people. And as I previously mentioned, one of the classification of images is also face detection or face recognition. So for example, application of this face detection or face recognition can be in case of privacy, where you have some kind of application and you want to blur an image of the face, so you don't recognize that person. Obviously, some of those applications are harder, like face detection or classification of handwritings. Some are a little bit easier to detect. Okay, so far in classification we had some predefined number of groups or classes, so C. However, in clustering we do not have predetermined classes. So there is no such assumption of how many groups we have. In clustering, actually, the grouping is done based on some kind of similarity or some kind of distance. So using that similarity, we will see what actually we mean by similarity. We will find some kind of natural groupings in the data that we have. So the groups will form based on how similar the objects inside the group are. So naturally, if we have, for example, our matrix X, when we know that each column is our variable and each row is the item, right, or person or similar. So if we want to cluster the items or people, we would use some kind of distance. That distance to you is known as a metric. So for example, Euclidean metric. So this is distance, the distance that you know between 2 points in a plane. And if you want to group or cluster the variables, you would use the correlation coefficient. So correlation between those variables, and this will measure how similar they are. If you do not recall metrics, then you can read in the suggested literature to remind yourself what is the Euclidean distance, or we already mentioned statistical distance. There are also many more metrics. Some of the mentioned ones are the Minkowski, Canberra metric, Chekhanovsky, etc. So there are many more. The choice of metric or the similarity that you're going to use depends on the problem that you actually have. We will only cover a couple of clustering methods. So we will do an exercise with clustering using binary variable and similarity coefficients. Then we will talk about hierarchical clustering methods. So there are single linkage, complete linkage, and error linkage. We will see what those means. And we will draw dendograms. And in the end, we will cluster using k-means method. There is also similar for method for classification. Even though we will cover all those methods on examples, it would be nice to go into book and read the selected theory behind it. The exercises here are the examples from the book, so respectively, one by one. So while watching the video, have a book near you, so it will be much easier for you to follow what are we doing step by step. Okay, so let's start with clustering using binary variable and similarity coefficients. Let's first open another PDF. Okay, so this one here. So this is an example from the book, so example 12.1. Let's first talk about the binary variables and the similarity coefficients. So this one here. What actually is a binary variable? So it is a variable that either has that some item or individual either has an characteristic or doesn't. So it can take values 1 if it has that characteristic, or 0 if the characteristic is not there. So there are many examples of such variables. In this case, we will use 6 binary variables. As you can see, some of them are for height, so somebody, some individual, is either higher than specific value or not. He or she weighs more than this or not. Either has brown eyes or some other type of eyes, etc. What are those similarity coefficients? So in table 12.1, you can see many different similarity coefficients. But what we need to introduce first is for the individuals, for example, for individual 1 and individual 2, we need to create a contingency table. So first, we need contingency table for all individuals. So not just for individual 1 and individual 2, but all possible combinations. What is this contingency table? It is a table that contains different numbers, so for different combinations of values of these variables. So for example, 1, 1 for individual 1 and individual 2 means that both have some characteristic. For example, if both individuals are higher than 72 inches, right, then we have 1, 1, so it is a match. So they're similar in that sense. They both have, they're both higher. Then, for example, they both can have brown eyes. So if individual 1 and individual 2 both have brown eyes, so it is again 1, 1 match. Then for A, for now we have 2. So A is 2. Why is A 2? Because both are higher than 72 inches, so we have 1. And both have brown eyes, so we have 1. So if we assume that they are both, for example, left-handed, weight less than this, not blonde, male, then A is going to stay 2. Similarly for the other pairs. So this is that individual 1 has that characteristic, but the individual 2 does not have. And then you go over how many times, so frequency of matches and mismatches for those two individuals, or in general items. Then, based on those matches and these matches, this will be a little bit clearer on the example on this one. But based on these numbers, A, B, C, and D, we can actually create different similarity coefficients. So you're always going to be given this one, but if you have to choose one, then depending on what you want, what should weight more, A, B, C, or D, then you can choose your own similarity coefficients. So for example, this A plus D divided by the sum of all of those gives equal weights for those. So A is 1, 1 matches, and D is our 0, 0 matches. Why equal weights? Because this sum is sum of all, okay, of all our possible combinations, let's say. And when we divide with our sum, so you can even look at this as separate, A divided by this plus D divided by this. And we can see that A and D have equal weights to our similarity, to our clustering. But there are different kinds. For example, if we just multiply any of those with, for example, 2, if we multiply B plus C with 2, then we will give double weight for unmatched pairs. Why? Because B is 1, 0 and C is 0, 1. So they do not match. For example, for 1, 1, they match, and for 0, 0 they again match. But for these two, they don't. So if you just in here multiply b plus c with 2, then you give double weight for those unmatched pairs. So they're twice as valuable to you. You can do the same for matched pairs. So if you do same for the matched pair, then you give double weight for the matches. Then when we have those similarity coefficients computed, then we can actually cluster items. So we will see how. What actually we want to cluster is those individuals based on those characteristics using these binary variables. So either you have that characteristic or you don't. So this is what binary means. But in this case we will use this similarity coefficient, so it gives equal weights to a plus b and c plus d. Usually the indicator a is higher than d. So if two individuals have a characteristic, some specific characteristic, that it is more likely that those two individuals are similar. So that's why sometimes we want to remove D. So we do not want 0, 0 matches, because it means that they both don't have that characteristic. But for example, if two individuals both don't like blue color, it does not necessarily mean that they're that alike. But if they both like some specific book or love specific type of movies, for example Marvel or anything, and they both love it, then they're likely to be alike. So here, as I mentioned, we give equal weight. So if we multiply both of those with 2, then we would give double weights to the matched pairs. This can differ, the similarity coefficients and the binary variables can differ. So this is something that can be on the written exam. So similar but with different binary variables and different similarity coefficient. But in general, you get it, the coefficient. Okay, so let's solve this exercise. So let's group these individuals, these 5 individuals. Let's see how are we going to cluster them based on this technique. Okay, so keep looking in this table, so these 6 characteristics, while I go to Excel. So have this PDF open somewhere, or book if you have book. Okay, so here we have that data. So we have height, weight, eye color, hair color, fatness, gender. Based on the table that we have, so the data in the book, we can, and the variables, we can now determine if the individual has that characteristic or doesn't. So, for example, for height, so we see that individual 1, their height is 68. Then we go to the binary variable and see that 68 is smaller than 72. So let's go for a second to the PDF. So we can see that 68 is smaller than 72. So it is this otherwise part. So we will give him 0 there. We do the same for individual 2, but they have 73 height. So it is larger or equal to 72. So we will put 1. Similarly for the rest. So for example, individual 2 has eye color brown. So we go to the binary variable that has the eye color. So we have here, okay, so individual 2, eye color brown 1. If we have blue, then we would put 0 here. Okay, so let's go back to Excel to see how it looks. So individual 1, their height is less than 72, their weight is less than 150, eye color is green, so it is not brown, so we put 0. Hair color, it's blonde, so for blonde we give 1. Are they left or right-handed. So right, 1. Gender, female, 1. And that way, from the table that we have, we can create this kind of table. So using the binary variables. Then we need to create those contingency tables and the tables for every pair of individuals. So 1, 2, then 1, 3, 1, 4, and 1, 5. So notice that 1, 5 and 5, 1 is same pair of individuals. So you do not need to compute both of those. Okay, so we want to see mismatches. So those would be 0, 0. Matches, that would be 0. Mismatches would be these two. So 0, 1 and 1, 0. And 0, 0 matches and 1, 1 matches. So how we can see this? Let's go for individual 1 and individual 2. So for example, here for height, we see that individual 1, okay, so individual 1 is here, has 0. So we would look here. And individual 2 has 1. So 1. So we would put here 1. Right. So how many times? So we have 0, 1 here as well. 0, 1 here as well. How many times do we have that 0, 1 mismatch? So 0, 1 we have 3 times. 1, 2, 3. 1, 0 mismatches. 1, 0. Okay, 1, 0. We have how many? 1, 0. 1, 0 and 1, 0. So 2. We have 2 those kind. We have 1, 1, 1 match. And we have no 0, 0 matches between those two individuals. So in that way we can create this contingency table. Those are totals. So when you sum those two, you will get 3. When you sum those two, you will get 3. So that's totals, and this is the total in general. You will see that the total in general will be 6 everywhere because we have 6 variables. Similarly, we can create all other tables. So for example, for individuals 1 and 3, we can see how many 0, 0 matches we have. So only 2. So we will put in 0, 0, 2. So we have 0, 1 here, right? And nowhere else. So 0, 1 would be 1. Then we have 0, 0. Okay, so we already covered that. 1, 1, 1, 1. So we have 2 1, 1 matches. So we will put 2 here. And in the end, 1, 0, 1. So as you can see, it's not that hard to create the tables, and you need to create all tables for all pairs. So in this case, we have those tables. But now we need to create, let's say, a matrix. So this matrix would be symmetric, whatever is here. So when you compute similarity coefficient for individuals 1 and 2, you should get same for both of those. So if you compute for 2 and 1 or 2, it should be same. Okay, and similarity between the same individual should be 1. So they're similar. Okay, let's go to the PDF. So we can see here, just a second, our similarity coefficient with equal weights. Okay, so we need A plus D, so 1, 1 matches, 0, 0 matches, divided by the sum of all. Okay, let's go back to Excel and compute for each those similarity coefficients. So for example, for 1, 2, so we want to compute this coefficient here. So we have A, B, C, D, right? So here it is A plus D, so 1 plus 0. So we can type here 1 plus 0 divided by the sum. So the sum here is 6, and what we get is 0.17. Okay, you can even write this as fractions, so it is written in book like that. Then we do the same for 1 and 3. So we find 1 and 3. a plus d divided by 6. Then we go like this. So a plus d divided by 6. Then for 1, 4, find the table and compute it. 2 plus 2 divided by 6. So if the similarity coefficients would be something else, for example, 2a plus d divided by 2a plus d plus b plus c. So when we give double weights, then you would need to use this to compute the similarity here in this matrix. Then we proceed, and for example, let's do 1 again. So for individual 2, okay, and individual 4. So for those two, we find the table, and we go 2 plus 1, so it's 3 divided by 6, and then we need to find it here. Okay, so it would be here, for example, or it would be, so the opposite, for 2, we get the same as we just mentioned. Now, when we compute the similarity coefficients, then we want to see which two individuals are the most similar based on this similarity coefficient. We'll talk later about if this is a good choice actually. So for example, we can see here we have 0.83, so it's the highest among all. So we can say that individuals 5 and 2 are the most similar. So we can put those two individuals to form one group, so one of our clusters. And the others, we can see that one is most similar to 3 and 4. Right, so we can put 1, 3, and 4 in one cluster because of this, let's say, relatively high similarity coefficient, and 2, 5 to be another cluster. So you can create those subgroups in different ways, but this one is the most appropriate here. However, we used the similarity coefficient mentioned there, but we are not sure if that is the right way. So do we actually want this similarity coefficient? Well, in this case, we might choose some other similarity coefficient. So this one gives equal weights to mismatches and matches. But we actually don't care if two people do not have brown eyes, because they can have blue, they can have green, right? So in that case, if we have two individuals, one with green and one with blue eyes, okay, so in that case they're not similar in this sense, right? So we give to blue eyes and green, we have 0, 0 match, and we equal those the same as, for example, if two people have brown eyes. But if two people have brown eyes, they're more similar than two individuals that one has green and the other has blue. Right, so in that case, we might want to choose some other similarity coefficient. But this is just for example. So this is it for this one. So what did we create? Subgroup 2, 5 and 1, 3, 4. How did we do it? Based on the numbers here. What would differ if instead of individuals we would like to cluster variables? Well, only the similarity coefficient. So we would use some correlation coefficient instead. But basically we would do the same. So we would not have some p here, but instead we would have n, so it would be 5 and similar, but the procedure is the same. You can look at some examples if you wish, but this is the only example that we will do. Of course, there is much more to this, but we will not cover everything, just to get the sense of it. Let's see what is our second method. So here, hierarchical clustering method and different types. single complete average, and something that we call dendograms. So what actually is this hierarchical clustering? So in this case, we either start with all individuals. So for example, if we had 5 individuals, like here, we start with all 5 and then we group them together. Or, so what I mean, we start with all 5. So this one would be one cluster, this one would be another, so another group. So we would have 5 groups. And then we, based on something, we would merge those two, for example, or those two, etc., until we get to the end, until we get to the one cluster, and then we can choose. Or we can start with one cluster containing all, and we can go backwards. So it's called a series of successful divisions. So we will somehow divide into clusters. So the first one is called agglomerative hierarchical method, and the other one is divisive hierarchical method. So the one starts with grouping, so starting with all 5 divisible, and we then create. So we first create in the divisive hierarchical methods, we create 2 subgroups that are the least similar, let's say, or far away or similar. And then we continue until each one is its own group, its own subgroup. Then we mentioned something called dendograms. So this can be seen as some kind of plot where you display those clusters or those groups, and it is somehow related to how you merge them. How do you merge individuals, or how you divide them? And when do you do that? In which step? So it contains everything. So mergers or divisions, as well as when you do that. When did you merge? We will only consider agglomerative, so the ones where you start with all 5 individuals and then you somehow merge them. And we will use that method, so linkage. So we'll somehow link those, let's say, those individuals. So I talked only about individuals, but you can do the same for variables. But not all hierarchical methods can be used for both. These ones, linkage methods, can be used for the individuals and for variables. Let's see what each of those means. So what would be single linkage? So we would find a minimum distance between the individuals. So the minimum distance in a sense of a metric. So one of the distances is Euclidean distance. So let's say a line between 2 points. Complete linkage means that we actually take the maximum distance between those, between clusters. For example, if we have 2 clusters, okay, so we find the 2 items or 2 individuals that are the furthest away in those 2 clusters. So it is illustrated nicely in a book. You may see figure 12.2. Okay, so there you can actually see that minimum distance between 2 clusters, or that maximum distance between 2 clusters, or the average one. So the average, you just average all the distances. So you would sum all the distances and divide by the number of individuals you have in both of those clusters. So similarly on the example in the book, so if you have 2 elements in one cluster and 3 elements in another cluster, okay, so you would use 6, so 2 times 3 would be the number of distances that you have from the cluster 1 to the cluster 2. So 1 can be paired with all 3 and we compute all distances. Then we take an individual number 2 and we compute all distances with all 3 from the another group. And in that way, as you can see in the book, we can find average. So we sum all distances and divide by all combinations, so 2 times 3. Okay, let's explain these concepts now on an example. So we will create dendograms and see how does single, complete, and average linkage work in this type of clustering. Okay, so to avoid calculating the distances, so the formulas, if you have data and you have a specific metric or similarity, then you can create those distances yourself. But here we will consider that those distances are already computed. So for example, this would be distance between individual 1 and individual 2. So our metric. If somebody does not know what metric is, you may ask. So for example, distance between 2 and 1 is 9. So here you would have 9 as well, right? So distance between 3 and 1 is 3. What are we using is our clustering method, but hierarchical and single linkage for A. Then we will see the complete and average. How do they work? So let's go to Excel, just a second. Okay, so here we have this table of distances between two individuals. Okay, or items, objects, whatever. Okay, so what we need to find, because now in this first step, every individual, 1, 2, 3, 4, 5, is on group. So we have 5 groups. Okay, now we want to find distance, that is the least distance between two individuals, and merge them, because this is single, so we need to find minimum, and merge them in one cluster. Okay, so we can see distance between 1, 2, 1, 3, 1, 4, 1, 5, 2, 3, 2, 4, 2, 5, etc. and find which one is minimum in our first step. So because we skipped this step of computing distances, what we know that the distance, the least distance based on this is 2. Okay, so this means that in our first step we will merge 3, so individual 3 and 5 into one cluster. So we do not have an 5. Okay, now we would have, so we merge 3 and 5. So we can, for example, okay, so 3, 5, let's say, and we can put here 1, 2, 4. Okay, so now we have 1, 2, 3, 4 groups. Now we need to create distances between those clusters, but still we use this minimum distance. Okay, so we have 4 clusters, 1, 2, 3, 4, 3, 5, and 4. Distance between 1, 1 still remains the same. Distance between 2 and 1 still remains the same. But what is the distance between our individual 1 and our cluster 3, 5? Well, the distance is minimum of 2 distances. So we need to find minimum of distance between 1, 3 and 1, 5. Let's see. Distance between 1, 3 is 3 and distance between 1, 5 is 11. So what is smaller than those two numbers? Well, smaller is 3. So we will put 3. Okay. This is our minimum distance between those two. And minimum distance between clusters 1 and 4 still remains the same. Let's see, between 2 and 2 is still the same. Then 2 and this cluster, so minimum distance between 2 and 3 and minimum distance between 2 and 5. 2, 3, 7, 2, 5, 10, so we will put 7. let's see, between cluster 3, 5, and 4. So distance 4, 3, and 4, 5. So let's see, 4, 3 is 9, and 4, 5, no, 4, 5, yeah, 4, 5 is 0, or no, sorry, 4, 5 is 8. So 8, and what did I say, 3, 4 is 9, and 8, so minimum between those two distances is 8. Okay, now we formed all distances, but now between those 4 clusters we do not have 5 anymore, right? So now in this step we still need to merge 2 clusters. Which 2 are we going to merge? Okay, think a little bit. So we need minimum distance. Where is the minimum distance? It is here, right? 3. So we will put 3. Now this one means that we need to merge 1 cluster and our second cluster 3, 5. So we need to merge those 3. So 1, 3, 5. Okay, and 2, 4. So now we have 3 clusters. We need to create distance matrix again, but with our new clusters. Okay, so we put 0 here, and now we need to find distance between 2 and 1, 2, 3, 2, 5. So minimum distance. So we can either use this matrix, okay, but if you have a lot of those, some kind of sorters may be overwhelmed or cannot compute this as fast, so you can use those distances as well. So the distance between 3, 5 and 2, so 3, 5 and 2, 3, 5 and 2, so 7, and distance between 1 and 2, that is 9. So we can find minimum of those 2 values, because now we have already minimum distance between 2 and 3, 5, which is 7, so we do not need to check here. So we just compute those 2 distances, so we will put 7. Same here, 4, between 4 and 3, 5, so 4 and 3, 5 is 8, and 4, 1 is 6, so we will put 6. Okay, and 4, 2 remains the same. The minimum distance in this distance matrix is 5. So we have 5, and we need to merge 4 and 2. So now 4 and 2 form one group, 1, 3, 5 form another one. Okay, and we repeat process. We can create the distance matrix once again to see that the minimum distance between those 2 clusters now 1, 3, 5 and 2, 4. So what is the minimum distance here? So distance between 1, 3, 5 and 2 is 7, and 1, 3, 5 and 4 is 6. So the minimum of those 2 is 6. So we will put here 6. Okay, and in the end it means we need to merge all clusters together, and this is how we finish the process. To see the dendogram, open page 684, and you can see figure 12.3. Okay, so this is the dendogram for these distances of our objects. Okay, so the branches in this some kind of tree are clusters. Okay, so you can see here in Excel as well how we create it. Then those branches, when they merge, okay, those positions, or wait, let me just a second. Okay, so here. Okay, so this is the dendogram. Here we have distances, and we start with all our individuals here, 1 to 5, as we did in Excel file. First, we merge 3, 5. Okay, when did we merge 3, 5? 3, 5 at distance 2. You see the bold one. Okay, so we go back here. So we merge here and at distance 2, 3, and 5. And we know that we first merged 3 and 5 because it's first here. So this would be first merge, second merge, third merge, and the final merge. When did it occur and at what distance? Okay. So then we merged clusters 3 and 5 and 1. At what distance? Okay, let's go back to Excel just to check. It is 3. Okay, so the bold one. Then we just plot it here. Okay, so distance 3, distance 5 the last, and the last one distance 6. So this is our dendogram for individuals and distance here, where we used single linkage. Okay, how do we know how to choose clusters? Are we going to choose 3, 5, 1, 2, 3, or how would we decide which cluster is the best? Well, in general, you would need a little bit more investigation or plotting just to see how did you form the clusters. But in this case, for example, you could choose, you can, let's say, cut it here. In this case, you would have clusters 1, 3, 5, and 2 and 4. So you would have 3 clusters. If you cut it here, then you have 2 clusters, 1, 3, 5, and cluster 2, 4. Okay, so you perhaps would cut it here and you would have 2 clusters if you want 2 clusters. Okay, let's see complete and average linkage. So it is really similar to what we have done so far. Again, here for the complete linkage, we start with the minimum distance. So in all cases, we will start with the minimum distance in the first step. The following steps, we use either minimum, we use maximum, or we use average. Okay, but first step, we find the most similar. So 3 and 5. They are the most similar because the distance is the smallest. And then we just, instead of minimum distances, we take maximum. So between 1 and 3 and 1 and 5 is what? Maximum 11. So we will put 11 here. Then between 2 and 3 and 2 and 5, 2 and 2 and 3, 2 and 5, 7 and 10, we will put 10. Okay. Here is 0. And the rest remains the same, the distances, the same way that we did. Okay, so we first merged 3 and 5. Then we need to, from this matrix, compute another distance matrix. Okay, but now we have 1, 2, 3, 3, 5, 4, and we have this matrix. We first need what to find? Which distance? The most similar one. Which is the most similar? 5. Okay, so we used, let me repeat again. Here we used minimum distances. Here we use maximum distances. Here we will use average distances. But we still choose minimum distance here to merge. Okay, but we use maximum to compute the distances. This might be a little bit confusing. So again, we take maximum distance between cluster, but the similarity, for the similarity, we still merge most similar, so the minimum distance. So here we will merge clusters, so 2 and 4. So now we will have clusters 2, 4, 3, 5, and 1. So we will have 3 clusters. Okay. Now we need to compute distances. Let's see. Distance between cluster 1 and cluster 3, 5 is what? So distance between 1, okay, and 3, 5 is 11. And distance between 1 and cluster, so which cluster we have? 1 and cluster 2, 4. So 1 and 2 is 9, 1 and 4 is 6. What is maximum between 6 and 9? It's 9. So we put 9. Then we need to compute distance between maximum distance between clusters 3, 5 and 2, 4. Okay, so we have 3, 5, 2 and 3, 5, 4. Let's see. 3, 5, 2 is 10 and 3, 5, 4 is 9. What is maximum between those two? It is 10. So maximum distance between those two is 10. So now we have this distance matrix, which we are going to select the most similar, 9. Okay, so this means that we will merge clusters 1 and cluster 2, 4, or groups. Let's say groups. So we now have 1, 2, 4 and 3, 5. Okay, so the one group is individuals 1, 2, 4. The second group are individuals 3 and 5. And in this case, we can compute the maximum distance, so it is 11. Okay, and we create this last cluster that contains all our individuals in last step with distance 11. Okay, so you can create those tables in different ways. So you can move 2, 4 here or whatever. Just be careful how you compute the distances. The dendogram will look similar to the one that we have, but you just first we merge 3, 5 at distance 2. Okay, right. So it would be 1. Then we merge 2, 4 at distance 5, and then we merge 1 and 2, 4 at distance 9. And in the end, at distance 11, we merge all of them. You create the dendogram in the same way. It is given in figure 12.6. 12.6 figure. Okay. So what is here left? Another example, the average linkage. Okay. We use the same distance matrix. We start with 2, again minimum distance. We merge 3 and 5. Okay. Then what we need is to compute the average distances. So distance between cluster 1 and 2 stays the same, 1 and 4 stays the same because we merge only 3 and 5. But what is distance between our cluster 1 and our cluster 3, 5? Okay, so distance between 1 and 3 is 3, and distance between 1 and 5 is 11. So what we need is to sum those two, so 3 plus 11, okay, and divide it by 2. We have two distances here, and our average is 7. Let's see the distance between 2 and cluster 3, 5. Okay, so we can see here that the distance between 2 and 3 is 7, and distance between 2 and 5 is 10. Okay, and then we just divide it by 2, because we now find the average distance. And similar between 3, 5 and 4. So we find between 3 and 4, 3 and 5, and we average them. Okay, so this is our new distance matrix. And based on this, what are we going to merge? This one, right? Now again, we have 3 clusters, 1, 2, 4, 3, 5. We need to compute the average distances. Okay, so for distance between cluster 1 and our new cluster 2, 4 is distance between 1 and 2 and 1 and 4. You sum them and divide by 2, so you average them. Okay, here you also could use this matrix, but then you would need to be careful. Here it's easier. In this case, it's the same actually. But if you want to use distance between 3, 5 and 2, 4, you could use this as well. But you would need more time to do that. So 9 plus 6 divided by 2 is our distance between 1 and 4. What is our distance between our clusters 2, 4 and 3, 5? So this is the way that you average all the distances. So the distance between 2, 3, 2, 5, 4, 3 and 4, 5. Okay, you find them here, but you would need to divide by 4. Okay, because now you have 4 distances. And that way you compute distance between 2, 4, and 3, 5 clusters using the average distance. So what is the list here? 7, right? And this means that you merge 1, 3, 5, so 1, 3, 5, and 3, 5, and then in the end you average all the distances between 1, 2, 1, 4, 3, 2, 3, 4, 5, 2, 5, 4, and divide by 6 because you have 3 times 2, so you have 6 numbers here 6 distances, and in that way you get another average, which is here. And the same manner you create using the distances, and the way that you create clusters, you can create dendogram, so which looks similar to this one. So we first merge 3, 5, then we merge 2, 4, right? 3, 5, 2, 4, then 1, 2, 4, and in the end we merge all of them. Okay, and last but not least is one non-hierarchical clustering method that's called k-means method. So by non-hierarchical we mean that this is a technique to group individuals, not the variables, into k, in this case, k groups or k clusters. So we know how many clusters we want. This method is good because software can easily implement them. You can take large data set and you can get the output, so your clusters, how many you want. Before continuing, read the, let's say, algorithm how to create this k-means, those k clusters. So it is page 696 and it has 3 steps. Okay, so you can either start with k clusters and then do the following 2 steps that you can see, or either you can just take, for example, 2 elements, that's called centroids, and based on that you proceed and create clusters. We'll see actually what it means. This centroid, it's called centroid because it's mean of something. But let's see, we will describe this algorithm on example, so you can still read it in the book, but let's see how it works actually in practice, those steps. So we here are given 2 variables, x1 and x2, right, and 4 items. What we want is to use k-means method to create 2 clusters, so 2 means, let's say, two clusters of those 4 individuals. Okay, so see this data and let's go to Excel. So here, first initial, our first step is choosing k clusters. So you can choose literally any 2 clusters of the following 4 elements. So you can choose AC, AD, BC, BD, does not matter. You will still get what you need. But let's choose AB and CD. So we choose 2 arbitrary clusters. Okay, AB, this is our random, let's say, cluster, and CD. Now we need to compute that, what I called centroid. So it is a mean, obviously, because it is a mean. What would be naturally to be, for example, because we have this cluster AB of 2 elements, what would be natural to be the centroid or the mean? Well, you average the first coordinate and you average the second coordinate. Okay, if you have more, you would average more of those. So what we can see is we sum those 2 and divide by 2. Same here. So you can even look at this at some point in 2-dimensional plane, for example, 2 point. Okay, and similar for cluster CD. So this is the point that's, let's say, in the center of the cluster. So if you have 3 points, for example, one, let's call it X, Y, Z, and U. Okay, so imagine that this is a plane. Okay, so this is a plane. Okay, so what would be centroid here? Naturally, this element here would be centroid. Okay, so it would be like average the coordinates. In that way, we created this. So those are our clusters, and those are coordinates of the centroid. So 2, 2, and 1, 1. I mean -1, 2. So step 1 is finished. Then in the step 2, we need to compute some kind of distance. So what is the most natural to us is the Euclidean distance, but again, there are many more different distances. Now we need to compute the distance between those. But before doing that, let's right click here, select everything, right click, quick analysis, and in quick analysis you can go to charts and create scatter plot. Okay, here those are our points, right? And we chose to cluster, so maybe it's better to do it a little bit different, or actually it doesn't matter. So we have our points, -1, 1, it would be our point B. So this is our point B. -3, -2, so -3, -2 is our point D. Okay, but what we created is AB. This is our first one. So this and this is our first cluster, and this one. What is the average? Well, this is our centroid. It would be here. Okay, and the other would be what is our another AB is 2, 2. So 2, 2. It would be here. Our another centroid. Okay. What we need next, let's remove this, is the distances. So the distances between each individual and centroids. Okay. So this can be done in this way. So you select everything. And for the first centroid, okay, it would be just, this is just coordinates, so subtracted with corresponding coordinates. So 5 minus 2, 3 minus 2. Okay, then the second one is -1, -2. Okay, so it is -3. Then 1 minus 2, it is -1. Okay, so those are just the differences, but we need Euclidean distance, right? So what we need to do is actually take square root of the sum of squared distances, right? So we square distances and we sum them. In Excel, it can be written like this. So this matrix multiplication actually means that you squared and sum the distances. You can see that actually this is 3 times 3 plus 3 times 1, so you have everything, all the square distance. So here we have the classical Euclidean distance. So square root of the sum of squared differences. And here are differences for the another centroid. What I said is that we now need to compute distance between all. So between A and our centroid AB. So we have our square distances, and now we can compute distance between A and AB. Okay, so you can see that those use corresponding elements here because we are computing distance between, for example, here, distance between B and centroid AB. Let's go back to graph. Maybe it's easier to show what are we actually doing. So our centroid AB is here, so it is 2, 2. But we now compute, for example, distance between B and this centroid. So we compute this distance here, Euclidean distance. So if you can see. Then between A and B, C and etc. We do the same for BC. I mean centroid CD. So it is here, but we need to compute all distances between those, and those. But the Euclidean distances. Those distances are exactly the numbers given here. These numbers. You should be familiar with this kind of distance. If you're given another formula for distance, you just apply, instead of the square root of squared distances, then you just use the other formula. But if we have such exercise, it will be the classical Euclidean distance. So we have those distances. So what we can actually see from those distances? We can see that A is closer to centroid AB, but because it's smaller than this one. So the distance between B and centroid AB is larger than B and CD. So we would move this B to our cluster CD. Okay, so what we can see that actually we created another cluster, BCD, and this one will actually become only our cluster A. Okay, now what would be, because now we have two clusters, A and BCD. What would be our centroid for our cluster A? Well, it has to be only A, or 5, 3, because it does not have any other element, so we cannot find the mean. I mean, the mean is the item or whatever itself. Okay, then we need to compute the centroid for our new cluster BCD. Okay, for this one. So what we need to do is, let's go and create here, is find the mean between those three. So here we can actually see that it is minus 1, 1. Okay, how did we compute it? So this is point here, average. So this is our cluster, and average is here. Okay, how did we compute it? Well, just sum the coordinates and divide by 3. Sum the coordinates and divide by 3. So the classical way to find the mean. Now we have two clusters. So here we lost one from AB cluster. So we lost one element, one item. And for BCD, we moved B to this cluster. Okay, so that's why we recalculated the centroids. So to the cluster that received an item and to the cluster that, let's say, lost an item. Now repeat step 2 and find the distances. So this is just a way to find the distances in Excel in a fast way. But again, you can use it. You can create this function in many different ways. The Euclidean distance. So this is again our Euclidean distance, and we can see 0, 2, 2, 2. Okay, so did anything change here? Well, no. We will not add or remove any items. If we continue to do this, there are not going to be any more reassignments that will take place. So in that sense, we will create two clusters, A and cluster BCD. That's how are we going to cluster the items. So what you can check is starting with different kind of clusters. So for example, you can take B as one cluster and ACD as another cluster, or any other combination with that. So if you do the same procedure, you would always get to this conclusion. You may also notice in the book that you can use different criterion to form these two clusters. So for example, the minimum square distances, sum of the minimum square distances. Actually, just the sum of the square distances, but the notation is with minimum. So the minimum of all possible squared distances. So just go over it to see that other criterion to find the clusters. So for such exercises, what we did here, you need just calculator. So all of those are possible to be on the written exam. Okay, just to repeat, for classification, if anyone wants to learn more, you may choose a project for that. That would be it. See you some other time. Bye.